Hi students, welcome to this video session. My name is Samuel Chukwu Emeka. In this video session, we shall discuss exponential equations. What do we mean by exponential equations? Exponential equations are equations involving exponents. So that means that we have exponents that are put in an equation, put as an equation. So that means since it involves exponents, that means that we have to use the knowledge of the laws of exponents to solve them. And because it is an equation, we have to do what? Now, you know what I want you to always do when you have an equation, right? You know what I want you to always do? Equate, to check your work, okay? So that you make sure that your left-hand side is equal to your right-hand side. So we are going to check our work. We will solve the problems we have here, and we will check our work. It is 15 questions, so that we can have some varieties, and we shall check the 15 of them. Please, before you begin this video, it is highly recommended that you have the knowledge of how to solve linear equations. Okay, it's very highly recommended that you know how to solve and check linear equations, and that you know how to solve exponents. It's recommended that you know the laws of exponents and how to solve problems involving exponents using those laws of exponents. Alright, let's go ahead and start. Question 1, we have 2 raised to the power x is equal to 128. So when we have this now, we look at the left hand side, the base is 2 exponent x, and on the right hand side we have 128. What we have to ask ourselves is this: is there any way I can make this to be base 2? Is there any way I can make this to be base 2? Why am I asking that? Because if I can make this to be in base 2, then I can equate their exponents. So what we are saying is this: when you have an equation involving exponents, if you can make the left-hand side of the equation and the right-hand side of the equation to be the same base, then you can equate their exponents. So if you have an equation involving exponents, or if you have an exponential equation, okay, equation involving exponents, or what we mean exponential equations. Exponential equations. Then, number 1, make the base on the left hand side to be equal to the base on the right hand side of the equation. Okay? Make the base on the left hand side of the equation to be equivalent to the base on the right hand side of the equation. And once you do this, then you can now equate their exponents. Equate their exponents. Right? And once you equate their exponents, you can now solve for the variable. Solve for the variable. And after solving for the variable, what next? You now check your work. You check your work, check your solution using what? Using the original equation, original exponential equation. Now, some students come when they want to check their work, they check it from the modified equation. We don't do that. No, do not do that, please. Whenever you check your work, any problem involving equations, whenever you check your work, it is very important that you check it with the original equation to see whether your left-hand side will be equal to your right-hand side. Okay? How do you check your solution? How do you check it? All you need to do, when whatever you get for the variable, you substitute it. You substitute it in the original exponential equation to see whether your left-hand side is equal to your right-hand side. You know, I like equations a lot. Ask me why. Why do I like equations a lot? Because you know whether you're getting it right or wrong. By doing what? By checking. If you solve it, after solving it, if you check it in the original equation, if the left-hand side is not equal to the right-hand side, then it is wrong. Okay? It applies to all the equations, even radical equations. In radical equations, at least part of the solution will be correct. If not, I mean, if all of them is not, then part of it will be correct, and that part that is correct is the answer. All right, so that is what we are going to do. These are the steps. You might want to write it down. So we now have that 2 exponent x is, you ask yourself, what will if I raise base 2, to what exponent? When you raise base 2 to what exponent? What exponent are you going to raise base 2 to give you 128? And you know, this involves your knowledge of multiplication tables as well. Okay, it involves the knowledge of multiplication tables as well. Because you know that 2 times 2 is 4, 4 is 2 squared, 4 times 2 is 8, 8 is 2 cubed, 8 times 2 is 16, 16 is 2 exponent 4, 16 times 2 is 32, 32 is 2 exponent 5, 32 times 2 is 64, 64 is 2 exponent 6, 64 times 2 is 128, 128 is 2 exponent 7. And once they are the same base now, you can now equate their exponent. So our x is equal to 7. Once you have the same base on the left-hand side, same base on the right-hand side, you just equate the exponent. And then after that, you do what? You check. When we check, we want to write the main problem. 2 exponent x is 128. Then we write our left-hand side and our right-hand side. Our left-hand side is what? 2 exponent x. Our right-hand side is what? 128. Then we substitute. We substitute what we get. X is equal to 7. So which side has the variable? Now remember, this is the original equation. You have to check with the original equation. Which side has the variable? It is the left-hand side. So we substitute it that this is 2 exponent 7, and that gives us 128. 128 on our left, 128 on our right. We can drink some water, right? Or drink some coffee because it's cold. You know, this is a cold weather, so you drink some coffee to keep warm. Okay, don't mind me. Let's continue. Kind of like putting humor in mathematics. You know, you don't have to take it serious all the time. Okay, so the steps I listed is what we are going to use to solve this, right? All of it. The next one, 3 exponent 2x is equal to 243. So this means that 3 exponent 2x will give us 243, 3 times 3, 9, right? 9 times 3, 27, 3 cubed. 27 times 3, 81. And 81 times 3 is 243. Exponent x is equal to 1 over 64. Okay, some folks don't like fractions. And when they see this kind of fractions, they don't like it, right? Now, it's not good. You shouldn't take it as a problem at all. Okay, you should not take it as a problem at all. Now, when you see this kind, there are two ways I would do it. I will do it 2 methods, and whichever method you like, you choose. Okay. The first method that I will use to do this, 1/4 means 4 to the -1. Okay. Well, now we need, like I said, you need the exponents. Please, you need to view the videos on the playlist on exponents and exponential equations. It's important you view the video on the playlist. Then you would know what I just did now. So this will be equal to 64 to the -1. Now this means 4 -1 times x is equal to, now 64 is what? 64, 4 times 4, 16 times 4, 64. So this is 4 cubed, right, times -1. You see, this is 4 cubed, then times -1. So this is 4 exponent -x equal to 4, 3 times -1 is -3. So do you see that? You have to express it in the same base. You've got to. Okay, you've got to express them in the same base. You have to. So this, you can now equate their exponent, -x is equal to -3. And of course, if you divide both sides by -1, x will be equal to 3. Now this is the first method. Somebody else might say he or she does not like this way. So I put the second method. With this first method, you are dealing with negative exponents. Okay, with the first method, you're dealing with negative exponents. You converted the fraction to negative exponent. Now with the second method, we can have it this way. 1/4 exponent x is equal to, we can now say that this is 1/4 cubed. That is what we can say. And then we can now say this, that 1/4 exponent x is equal to 1 cubed over 4 cubed. Because you know that with 1, anything you raise 1 to, 1 as a base, if you raise the base to any exponent, it gives you 1. 1 squared is 1, 1 cubed is 1, 1 raised to power 5 is 1, 1 exponent Mr. C is 1. So you can now say that this is 1/4 exponent x equal to 1/4 exponent 3, because this is one of the laws of logarithm. One of the laws of logarithm. And you now have the same base. The base is 1/4, right? So you can now equate their exponents. And this is x is 3. Okay, so whichever method you use is okay. Now, let's go ahead and check our work and see whether we are correct. Alright, so we check, and when we check, we always check with what? The main problem. We're not going to check with this, no. We will check with the main problem. So we write the main equation 1/4 exponent x equal to 1/64. Our left hand side and then our right hand side. Left hand side is 1/4 exponent x. Right hand side is 1/64. And then left hand side is 1/4 exponent 3. Our x is 3, so we substitute it. And this means what? 1 cubed over 4 cubed. And that is 1/64. Right? So we are good. We can do some dance. Now, question 4. Let's keep moving on. Now, 3 exponent -x is equal to 1/81. And please, what I usually advise students who view my videos is that you pause, right? You pause now, try it, check it, see whether you got it right, then you play. Then you play so that you see whether we have the same answer. But like I mentioned, you know, earlier in the video, one thing I like equations is that you know whether you got it right or wrong. One thing I like equations for, okay, by checking your work. So that's nice. Now, we can solve these two ways. We can solve it two methods, okay? But I would just prefer to use one method, okay? But we can actually do it two methods like we did this. Yeah, although this will now be 1 over 3 raised to power x, right? And you can still say 1 raised to power x over 3 raised to power x, because 1 raised to power anything will still give you that thing. So you can have 1 to be 1 raised to power x. It's still going to be 1. Okay, but let's just do it with the first method. So this is 3 raised to power negative x will be 81 raised to power negative 1. Right? Now, when I say raised to power, it means exponent. You can say power, or you can say exponent, or you can say index. Because some of you might ask me raised to power what? It means raised to exponent. So this means 3 raised to power negative x is equal to 81 is 3 exponent 4. Then this is what? Times negative 1. Okay? Times negative 1. This is 3 exponent negative x equal to 3, 4 times negative 1. So 3 exponent negative x is equal to 3 exponent negative 4. So they have the same base. You equate your exponent. Negative x is equal to negative 4. X will be equal to 4. Now, what next do we have to do? We check. We have to check our work to see whether the left-hand side is equal to the right-hand side. Okay, so we check. And when we check, we see, we write the main problem. Then we write the left-hand side. And then the right-hand side. Left-hand side is 3 exponent negative x. Right-hand side is 1 over 81. Here, our x is 3 exponent negative 4. With your laws of exponent on negative exponents, this means 1 over 3 exponent 4, which is 1 over 81. So, 1 over 81 on your left, 1 over 81 on your right. You can drink some tea, but don't join the tea party. Okay. All right. The next one is exponent. What's wrong with me? I'm saying exponent. The next one is question 5. Question 5. Okay. 6 exponent 2x minus 1 equal to 216. Okay, so we shall do what we have been doing in previous questions. This is 6 exponent 2x minus 1. Please don't be scared now that you see that expression as your exponent on the left-hand side. Don't be scared. Do what you have been doing. 216 is what? 6 times 6, 36. 36 times 6. Is 216, right? Okay, 36 times 6 is 216, yes. So this is 6 exponent 3. So what you have to do, they have the same base, equate their exponents. 2x minus 1 is equal to 3, 2x is equal to 4, and x is equal to 2. Our x is equal to 2. Do we stop here? No, we check. So we now check. We write the main problem, 6, 2x minus 1, exponent 2x minus 1, equal to 216. Left-hand side, right-hand side. Left-hand side is 6 exponent 2x minus 1. Right hand side is 216. Then this will be 6, 2 times what? Our x is 2, 2 times 2 minus 1, which is 6, 4 minus 1, which is 6 exponent 3, which is 216. 216 on your left, 216 on your right. You can do some dance, you know. Okay, let's continue, please. Question 6. Two over 3 all exponent y equal to 8 over 27. Okay, you come back to fractions. Don't be scared, please. Do not. The same way we have been doing it. So this is 2 over 3 all exponent y equal to, this means 2 cubed over 3 cubed. Okay? 2 cubed over 3 cubed. 2 times 2, 4 times 2, 8. 3 times 3, 9 times 3, 27. So this is 2 over 3 exponent y equal to 2 over 3 all cubed. Do you see that now? They now have the same base, right? So our y is what? 3. Our y becomes 3. All right. How do you check this? We check it the way we've been checking it. We check it the way we've been checking it. We write our check. We write the main problem. We write the left-hand side, right-hand side. Left-hand side is 2 over 3, all exponent y. Right-hand side is 8 over 27. Now, why do we check with the original equation? Why? Why don't we check with the modified equation? Because our modified equation might be wrong. Okay, so that's why we check with the original equation. We don't check with the modified, we check with the original. So our y is 3, so this is 2 over 3 all cubed, which is what? 2 cubed over 3 cubed, which is 8 over 27. And then you can do some taekwondo, you know. Okay, question 7. Anytime you get it right, you should do something, okay? You should do something, you know. Do something, you know. Question 7 is this: 3 over 4 exponent k equal to 64 over 27. Okay, look at this question 7. Let's kind of look at it well. Now this will be what? 3 over 4 exponent k equal to, now this is 4 cubed over 3 cubed. You see that now? That's 4 cubed over 3 cubed. See, it didn't work like this one, like question 6. Because this will now give us 3 over 4 exponent k equal to 4 over 3 all cubed. We have a problem here. Now, if we look at question 6, the base is the same. So we easily equated their exponent. But here, there is a problem here. See that? Because the base here is 3 over 4. And then the base on the left is 3 over 4. And the base on the right is 4 over 3. We can't just equate the exponent. We have to make one to be the other. Now, we notice here that the base on the left is the reciprocal of the base on the right. And the base on the right is the reciprocal of the base on the left. So, your question is this: who do you make to look like the other? Do you make the base on the right to look like the base on the left? Or do you make the base on the left to look like the base on the right? Okay? And you don't, if you have this kind of situation, you don't want to tamper with the base that has the variable. The base that has the exponent as the variable, you do not want to tamper with it. So you have to make the base on the right to look like the base on the left. I'm sorry, conservatives. I don't mean making conservatives to look like liberals. No, no. This is just mathematics, okay? Don't mind me. So, after all, I'm also conservative in some things. Now, you want to make this now to look like this. And how do you do that? We see that this will now be 3 over 4 exponent k equal to, now we see that when we do 1 over, right, 3 over 4 all cubed. Because when you do 1 divided by 3 over 4 all cubed, you will get 4 over 3 all cubed. Let me show you that. Let me show you that right away. See what I mean here. When you have 1 divided by 3 over 4, it gives you what? 4 over 3. Because it will be 1 times 4 over 3, which is 4 over 3. When you have 1 divided by 3 cubed over 4 cubed, it will be 1 times 4 cubed over 3 cubed. And that will be 4 cubed over 3 cubed. And that will be 4 over 3 all cubed. What you had initially, do you see that? So I am just trying to do something, you know, because I have to make, they've got to be the same base. They have to be the same base. They have to, before you can equate their exponents. Okay? So this gives us 3 over 4 exponent k equal to, now this will be 3 over 4 all cubed, now all -1. Do you understand what I'm saying? Because this is -1. You know, when you raise it, when you raise, this is our definition of negative exponent. So this will now, so they have to be the same thing. So this will now be 3 over 4 exponent k equal to, now this will be 3 over 4 exponent -3. Because you remember the definition that we did on negative exponents, when you, the base with the positive exponent is the reciprocal of the base with the corresponding negative exponent. Okay, and vice versa. Base with a positive exponent is the reciprocal of the base with the corresponding negative exponent, and also base with the negative exponent is the reciprocal of the base with the corresponding positive exponent. We did that in the previous videos. So you now make it to look like that, and then this will now be that our k is equal to what? Our k will now be equal to what? -3. K is equal to -3. Now we get the exponent. Now, do we stop there? No. We have to do what? We check. We check our work, and in checking, we check from the main equation 3 over 4 exponent k equal to 64 over 27. Our left hand side, our right hand side. Left hand side is 3 over 4 exponent k, and right hand side is 64 over 27. So our left hand side will be 3 over 4 exponent, our k is -3, okay, and when you define this, right, this means what? From what we did, 1 over 3 over 4 exponent 3, which is what? 1 divided by 3 over 4 exponent 3, which is 1 divided by 3 cubed over 4 cubed, which is 1 divided by 27 over 64, which is 1 times 64 over 27, which is 64 over 27. 64 over 27 on your left, 64 over 27 on your right. You can dance, 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 dance. Okay. Question 8. We are moving on now. study question 7 very well and know the concept by which we got our answer. Question 8, 16 exponent x equal to 128. Alright, now in this case, we see that 16 times 1 is 16, of course. 16 times 2 is 256. Right? 16 times 2, this is 96, and this is 6, and this is 1. Okay, this is 256. So, guys, you see, this is not 256. So, what do we have to do here? If you look at it and you see that the base is not a multiple of the other, you know, so what do you have to do? You try and see whether you can express it in a smaller base, a common base. Since we cannot express 128, you know, as 16 exponents something, you know, since we cannot do that, then we have to look for a smaller base that we can. And the next thing, if we look at 4, we can express 16 is 4 squared, but 128, we don't have like 4 exponent, any whole number to give us 128. We do not. Because 64 times 4 is 256. Right? So, we're done. So, we try 2. We try 2. And we see that 2 will work. Because 16 is 2 exponent 4, then times x now. Equal to 2 exponent 7. See that? So that's the way we do it. So this means 2 exponent 4 times x equal to 2 exponent 7. So this is 2 exponent 4x equal to 2 exponent 7. You now equate their exponents. 4x is equal to 7. So x is equal to 7 over 4. You don't need to simplify to mixed number. No. Just leave your answer as an improper fraction. Alright, now let's go ahead and check this. Check our work. You've got to check it now. Check. So we write the main problem, 16 exponent x is 128. And we have our left hand side and our right hand side. Then our left hand side is 16 exponent x, right hand side is 128. And then our left hand side we have 16 exponent 7 over 4. Now, you know what this means, right? We did fractional exponents. I did that in videos on the exponents when I did laws of exponents. So view that video, please. It's important. So what does this mean? This means the fourth root of 16, all exponent 7. That is what it means. Fourth root of 16 is 2, because 2 times 2, 4, times 2, 8, times 2, 16. 2 exponent 7, and that gives you 128. 128 on the left, 128 on the right. Then the liberals and the conservatives can now drink some tea and Kool-Aid. Okay. Question 9, right? Question 9. 32 exponent p is equal to 16 exponent 1 minus p. Yeah, this is also the same case, right? Because 16 we cannot express it. Now, you know some students might do this. Please, let me caution. You know, I like whatever students might do, I know it because I have taught so many years, and I want to caution it. Please, don't come here and put 16 squared. Please don't do that. Don't come here and put 16 squared. Please don't do that. Please. Because something that is 16 times 2. No, we're talking about exponents. Not just, you know, 16 times 2. No, we're talking about 16 squared. And it's not going to work. So we try, and 4 won't work either, because 4 won't work for the 32. So we use 2. 2 will work. 2 exponent 5 up times p equal to 2 exponent 4, 1 minus p. So do you see what I just did now? You've got to be careful when you're doing this. You see, I have to put it in parentheses. See that? Please don't come and do 41 minus p. Please don't do that, please. Don't come and say 41 minus p. So now this will be 2 exponent 5 times p. I'm not skipping steps now. I do not want to skip steps. I am doing all the steps so that you can understand it very well. So this equal to 2, then 4. Now, because this is an expression, right? It means 4 times 1 minus p. That's what it means. So this is 2 exponent 5p equal to 2, 4 minus 4p. Okay? And then they have the same base now, so you can equate their exponents. So 5p is equal to 4 minus 4p. So minus 4p comes over here. This is now 9p equal to 4. So p will be equal to 4 over 9. P is equal to 4 over 9. Now, please, if you have if your question is, how did you get 9p? Then I will say, go to my website, view my video on linear equations. Okay? If your question is that. Okay, so our p is now 4 over 9. What do we do next? We do what? We check. And then we write our check. Then we write the main equation, main exponential equation. And then after that we write our left hand side and our right hand side. Our left hand side is 32 exponent p. Right hand side is 16 exponent 1 minus p. Now our p is 4 over 9, right? So this is 32 exponent 4 over 9. And then this is a 16 exponent 1 minus 4 over 9. Right? So we can go ahead and simplify this because you see you can't get 9th root of 32. It's going to give you a decimal. Right? If you do 9th root of 32, it will give you a decimal. So just go ahead and simplify this. This will be 2 exponent 5 then times 4 over 9. And then this will be 16. 1 minus 4 over 9 means 9 over 9 minus 4 over 9, which is 5 over 9. So this will now be 2 exponent 5 times 4 over 9. And this will be 2 exponent 4 times 5 over 9. So this will be 2 exponent 20 over 9. Right? And this will also give you 2 exponent 20 over 9. See that? Because 4 times 5 over 9 is 20 over 9. Because all you want to make sure is that your left hand side is your right hand side. And after that, you can drink some coffee because it's cold. Okay, question 10. 9 exponent 4j minus 2 equal to 1 over 729. So now we just have to do what we've been doing. Now we see that we can express this 9 because 9 times 9 is 81. 81 times 9 is 729. So that case is not like question 9 or question 8 that we did. Here we can express it directly. So what do we do first? We make 9 4j minus 2 equal to 729 raised to power exponent negative 1. Remember, negative exponents. I did that in previous videos. So this will be 9 4j minus 2 equal to 729 is what? 9 cubed. That's negative 1. Okay? So this is 9 4 exponent 4j minus 2 equal to 9, 3 times negative 1. So 9 exponent 4j minus 2 equal to 9 exponent negative 3. So now you can equate their exponents. So this is 4j minus 2 equal to negative 3. 4j will be equal to negative 3 plus 2. And then 4j will be equal to negative 1. J will be equal to negative 1 over 4. Negative 1/4. J will be equal to negative 1/4. The next thing we have to do is to do what? Check our work. We now check. We write the main equation first. 9 exponent 4j minus 2 equal to 1 over 729. Then our left hand side, our right hand side. Our left hand side is 9 exponent 4j minus 2. Our right hand side is 1 over 729. Alright, so our left hand side has the j. So this is 4 times negative 1 over 4 minus 2. So this is 9. 4 divided 4 is 1. Negative 1, negative 2. So this is 9, negative 3, which is what? 1 over 9 cubed, which is 1 over 729. And then you can speak like me. Okay. The next question, question 11. 8 exponent 3k plus 2 equal to 1 over 32. So in this case, we see that we can express 32 directly as an integer exponent of 8. Okay, we cannot. But first of all, let's make this fraction to be a negative exponent. This is 8, 3k plus 2 equal to 32 exponent negative 1. So we can't do that with 8 and 32. So we used to. We can also do that with 4. It won't work. Now 4 squared is not 8. Some students might say that 4 squared is 4 times 4, which is 16. It is not 4 times 2, which is 8. It is not. Please. 8 is 2 cubed. 2 cubed, then 3x plus 2. You see, I put this in parentheses. Once you're converting it to exponent to another base, put the parentheses, okay? Please. Equal to 2 exponent 5, then negative 1. So this is 2, 3 times 3k plus 2 equal to 2, 5 times negative 1. So this will be 2, 9k plus 6 equal to 2, negative 5. So you can now equate their exponents. We now have that 9k plus 6 is equal to negative 5. Okay, and we finish this up and then check our work. So 9k will be equal to negative 5 minus 6. 9k is negative 11 and k will be negative 11 over 9. Do you stop here? No. You do what? You check. So we write the main problem. A, 3k plus 2 equal to 1 over 32. Then you write your left hand side and your right hand side. Your left hand side is what? 8 exponent 3k plus 2. Right hand side is 1 over 32. So our variable is on the left hand side, so we use it. This will be 8, then 3 times negative 11 over 9 plus 2. And that is 8. 3 into 3 is 1. 3 into 9 is what? 3. So this is negative 11 over 3 plus 2. And that is 8. Negative 11 over 3 plus 6 over 3. Right? So they now have the same denominator here. So this is 8 negative 5 over 3, right? Which is what? Cube root of 8 all exponent negative 5, which is what? Cube root of 8 is what? 2 exponent negative 5, which is 1 over 2 exponent 5, which is 1 over 32. 1 over 32 on your left, 1 over 32 on your right. You can do some jumping. Do some jumping. You know. Now, please, I have talked about this. Okay, I've talked about it. If you cannot see it clearly, let me write it. Let me write it here. If you didn't see that clearly, I can write it here. So we say that this is the left-hand side, 8 3k plus 2, which is 8, 3 times negative 11 over 9 plus 2, which is 8. 3 into 3 is 1, 3 into 9 is 3. So 1 times negative 11 is negative 11 over 3 plus 2, which is 8. Negative 11 over 3 plus 6 over 3, which is 8, negative 5 over 3. And this means what? Cube root of what? 8 raised to power negative 5. Cube root of 8 is 2, so 2 exponent negative 5 is what? 1 over 2 exponent 5, which is 1 over 32. So that is what we got. Alright, question 12. Question 12. 10 exponent x equal to 0.001. Now this is 10 exponent x equal to... Okay, look at this now. 0.001 is what? You know what it is, right? It's 10 exponent negative 3. Because this means, you know, because this is 0.001 means 1 over 1,000. Let me kind of break it down. So this means 1 over 1,000. Because this is 1, 1, 2, 3. So this is 10 raised to the power x is 1,000 exponent negative 1. So this is 10 exponent x equal to 10 exponent 3 times negative 1. 10 exponent x is 10 exponent 3 times negative 1. 10 exponent x is 10 exponent negative 3. And x will be negative 3. Right? Then you do what? You check your work. You do what? You check your work. You check your work. Okay, check. We write the main problem. 10 exponent x is 0.001. Our left-hand side, our right-hand side. Left-hand side is what? 10 exponent x. Right-hand side is 0.001. We got our x as negative 3. Which side has the variable? Left-hand side. So this is 10 exponent negative 3, which is 1 over 10 exponent 3, which is 1 over 1,000, which is 0.001. And then you can dance, you know. Okay. Once you get your work by checking, you do what? You do something. Do something. Do something. Now, this is question 13, so we can finish up. 81 times 3 exponent x is equal to 9 exponent x. Right? You know, we start from the simple questions to the more challenging questions, you know. But you know they're not challenging to me anyway. Come on. Okay, so how do we solve this? The minimum base is 3. So let's try to express everybody in 3. Okay? The minimum base there is 3. Let's express everybody in 3. So this is what? 3 exponent 4 times, because this means times, 3 exponent x equal to 3 exponent 2. Then you put the x. Remember, whenever you put this to another base, put it in parentheses, please. Put it in parentheses. So this means what? 3, 4 plus x from your laws of exponent. From the laws of exponent equal to 3, 2 times x, which is 2x. So they have the same base, so what you're going to do? Equate their what? Exponent. 4 plus x is what? 2x. So 4 is equal to 2x minus x. 4 is equal to x. X is equal to 4. X is 4. Right? Do you stop here? No. What do you do? Check. So we check. We write our main problem. 81 times 3 exponent x equal to 9 exponent x. What is our left hand side? What is our right hand side? Left hand side is 81 exponent 3 times 3 exponent x. Right hand side is 9 exponent x. So both of them have the x. Is that right? Yes. Both sides contain the variable. So we're going to use both sides. So this is 81 times 3 exponent 4. This is 81 times 81. Okay, 81 times 81 is what? 81 times 81, this is 81 times 1, 8. 8 times 8, 64. So 1, 8 plus 8 is 16. Then 5, 6, 5, 6, 1. 6, 5, 6, 1. 65, 61. And this will be 9 exponent 4, which is 9 times 9 times 9 times 9. 9 times 9, 81 times 9, 729. 729 times 9. 729 times 9. 9 times 9, 81. 8, 1, carry 8. 9 times 2, 18 plus 8, 16. 18 plus 8 is 26, I'm sorry. Then 9 times 7, 63, plus 2, 65. 6521. 6561. So this is 81 times 81, 6561, and then 729 times 9, 6561. You can do some karate, you know. Okay, question 14 is next. Eight exponent 2p times 4 exponent 2p minus 1 equal to 16. All right. If you look at this now, the smallest base is 4. But we cannot express 8 as an integer exponent of 4. And we cannot, so we cannot express it. So we just use another smallest base, which is what? 2. We use something we can express with, okay? We use something we can express with. So 8 is 2q, then 2p times 4 is 2 squared, then 2p times 2p minus 1 equal to 2 exponent 4. 16 is 2 exponent 4. So this is 2, 3 times 2p times 2, 2 times 2p minus 1 equal to 2 exponent 4. So this is 2, 3 times 2p is 6p times 2, 2 times 2p is 4p minus 2 times 1, 2 equal to 2 exponent 4. Now, they have the same base, right? So, and they are multiplying. So we add the exponents. So this is 2, 6p plus 4p minus 2 equal to 2 exponent 4. I know why I put parentheses. When you're adding or subtracting, please put parentheses, okay? I know it's adding, but go ahead and put parentheses, then you can release it later on. So 6p plus 4p minus 2 is equal to 4. 6p plus 4p minus 2 is 4. 10p is 4 plus 2. 10p is 6. P is 6 over 10. So p is 3 over 5. P is 3 over 5. But I'm not sure of my answer. I'm not sure whether I am right until I do what? Check. So I've got to check now. Gotta check. So I write my main problem. A 2 exponent p, then 4 2p minus 1 equal to 16. Then the left hand side, right hand side. Left hand side is 8 exponent 2p times 4 exponent 2p minus 1. Right hand side is 16. So my left hand side is the one that has the p. Okay. So this is now 8 times 2 exponent 2 times 3 over 5 times 4 exponent 2 times 3 over 5 minus 1. Now this gives me 8, 2 times 3 over 5 is 6 over 5 times 4, 6 over 5 minus 1. Okay, I know that my right hand side is 16, so let me do something and get my left hand side. So this will be what? 8 exponent 6 over 5 times 4, 6 over 5 minus 5 over 5. Right? And continue here, this will be 8 exponent 6 over 5 times 4, 1 over 5, exponent 1 over 5. Okay, we can't get the fifth root of 8 to give us a, the fifth root of 8 will not give us an integer. And also the fifth root of 4 will not give us an integer. It will not. And we don't want to do fifth root of 8 exponent 6 because that's another thing we can do. We can first of all find 8 exponent 6 and then do the fifth root. That will waste time, honestly. It will waste time. So let's go ahead and still convert this to base 2. This is 2 cubed times 6 over 5 times 2 squared times 1 over 5. So this will be 2. 3 times 6 is 18 over 5 times 2. 2 times 1 is 2 over 5. So this will be 2. 18 over 5 plus 2 over 5, which is 2. 20 over 5, which is 2. 4, which is 16. Because 20 divided by 5 is 4. And 2 exponent 4 is 16. 16 on your left, 16 on your right. Can do some dancing. No? Alright. Then the last but not the least. The last but not the least. Question 15. 2 exponent 2x minus 1 times 2 exponent x plus 2 equal to 128. Right? Okay, so this is pretty straightforward. We've got to just express this in base 2, and we've got to apply we have to apply our laws of exponents here. Well, let's open up the parentheses, okay? Times 2x plus 2 is equal to 2 exponent 7. So this will be 2x minus 1, let me put it in parentheses, plus x plus 2 equal to 2 exponent 7. So this will be 2, let me open up the parentheses, 2x minus 1 plus x plus 2 equal to 2 exponent 7, which is now 2x plus x is what? 3x, minus 1 plus 2 is what? Plus 1, equal to 2 exponent 7. So I can now equate, come over here, I can equate my exponent, 3x plus 1 is equal to 7, 3x is equal to 7 minus 1. 3x is 6. And x is 2. X is 2. Alright. Do we stop here? No. Do we know whether our answer is right? No. Do we know whether we are correct? No. Until we do what? We check. Alright. So, we check our final question. Let's check our answer of the final question. I wouldn't have erased it, you know. I'm sorry. You can pause the video, okay? You can just pause the video. Okay. So this is 2x minus 1, then times 2, x plus 2, equal to 128. So we write our left-hand side and our right-hand side. Our left-hand side is what? 2x minus 1 times 2x plus 2, and our right-hand side is what? 128. Now, which side has a variable? Only the left-hand side. Okay. So let's substitute that. This will be 2 times 2 minus 1, then 2 plus 2. So this will be 2 times 2 is what? 4, minus 1 times 2 plus 2 is what? 4. So this will be 4 minus 1 is what? 3, times 4. Right? And that is 3 plus 4, and that is 2 exponent 7, and that is 128. 128 on your left, 128 on your right. Then let's move, you know. Let's move campaign to make sure you burn fat. Okay. Thank you for listening to this video presentation. Please, I would always want you, as usual, anytime you solve equations, to check your work. And if you have any questions, please feel free to ask me in class, or feel free to contact me. Thank you so much for listening, students, and you have a great evening.